Hello everyone, welcome to today's video. Today's video is all about another topic of testing of hypothesis. That is, we are going to cover another topic of testing of hypothesis, that is chi-square test of independence. We will be doing chi-square test of independence using HR analytics, that is, we'll be using HR data. I will also show you how to implement chi-square test of independence using HR data in SAS. Now the agenda of today's session is, first we are going to cover the introduction, that is, I'll be introducing you to the project that we are going to work for chi-square test of independence, the primary goal of our project, the concept of chi-square test of independence, and then we'll move to the practical implementation part. So first let's understand our goal objective of our project. So we are provided, a company survey is done and we are provided with the data where the job satisfaction and the employee engagement of all employees of the company are noted. And our objective is to understand or investigate the potential relationship between the two categorical variables. That is, we are going to check whether the two categorical variables, that is job satisfaction and employee engagement, are associated to each other or not. You need to understand something, that chi-square test of independence of attributes only gives you the result that whether the two factors or the two categorical variables are associated to each other or not. They do not measure the degree of association between the two factors. So only you will get the result and your interpretation will be that whether the two categorical variables are associated to each other or not. So employees across different departments, their job satisfaction and employee engagement are collected. The job satisfaction variable are of three categories, that is, it's high, medium or low. And employee engagement also has three categories, that is maximum, minimum or moderate level of employee engagement. Now, in order to do chi-square test of independence of attributes, we have to set a hypothesis. The null hypothesis for this test is there is no significant relationship between the two factors, that is job satisfaction and employee engagement. And alternative hypothesis, that is H1, is there is a significant relationship between the two factors, that is job satisfaction and employee engagement. The level of significance which is by default set in chi-square test of independence is 0.05, that is 5%. Now if your p-value or your probability value is less than alpha, that is alpha is your level of significance, then you will reject the null hypothesis, which is your H0. And if your p-value is greater than equal to alpha, then you will fail to reject H0, that is, you will accept your null hypothesis. Now if your H0 is rejected, that denotes that there is a significant relationship or there is an association between the two categorical variables. And if your H0 is accepted, that suggests that there is no association or there is an insignificant relationship between the two factors or your categorical variables. Now the primary goal of our project is to analyze the relationship between the two factors, which are job satisfaction and employee engagement. Now let's discuss about the objective of the project. A company survey is done where the job satisfaction and employee engagement are noted. The company wants to analyze the relationship between job satisfaction and employee engagement. Now what is the objective and purpose of chi-square test of independence? First you have to understand the concept of the chi-square test of independence, and then you have to test and check whether there is a significant relationship or association between the two categorical variables or not. So that using the chi-square test of independence, you are going to check whether the two categorical variables are associated to each other or not. Now these are certain key terminologies that you will come across when you do the chi-square test of independence of attributes. First is we'll be dealing with categorical variables, where the categorical variables have specific groups or specific categories. There is a contingency table. Contingency table is a cross-tabulation frequency table of the categorical variables. You have a set of hypotheses, that is a null hypothesis and alternative hypothesis. Null hypothesis, that is H naught is, the variables are independent, that is there is no association between the two categorical variables. Alternative hypothesis is the variables are not independent, that is there is an association between the two categorical variables. And you have by default set value of your level of significance, which is denoted by alpha, that is 5% or 0.05. Now, you need to understand that when you will be applying a chi-square test of independence. Chi-square test of independence you need to apply when you have two categorical variables in your data, and when you need to understand whether the two categorical variables are associated to each other or not. Now, let's discuss the assumptions of the chi-square test of independence. The first assumption is the observations should be independent, that is they should not get influenced by each other. Second, expected frequency in each cell should be at least 5. Now, what is a contingency table in a chi-square test independence of attributes? Contingency table is a cross-frequency tabulated table where you have the distribution of data across the categories of the two categorical variables are given, or the cross-frequency distribution of data of the categories in your category variables are given in the contingency table. Now, how will you take decision based on the result of your chi-square test independence of attributes? According to the p-value approach, you will be getting a p-value or probability value in chi-square test independence of attributes. If your p-value or the calculated p-value is greater than the level of significance, which is by default 0.05, then you will accept null hypothesis, which denotes that there is no association between the two categorical variables. And if it is less than 0.5, if the p-value is less than 0.05, then you will reject null hypothesis, showing that there is an association between the two categorical variables. Now let's move to the practical part of how to implement the chi-square test of independence of attributes using SAS. So let's now do chi-square test independence of attributes using SAS. We are provided with data where the employees' job satisfaction and their employee engagement are given, and we are going to assess whether these two categorical variables are associated to each other or not. So first, what I have done is I have created a folder from files, right click on it, new, then folder. I have created a folder called HR Analytics, inside which I have uploaded the dataset of chi-square test, that is hr_chi.csv. Now, using this HR Analytics folder, I will be creating one library using the libname statement, that is libname is the keyword to create library. HR is the name of my library. You can give any name to your library, and then within the quotations I have given the path of my HR Analytics folder. So you can just right click on the HR Analytics folder, go to properties, copy the location, so this is the location. Now we are executing the libname statement to create the library. So see, your HR library is already created. Go to libraries, my libraries, and see this is your HR library. Now I will be importing my raw data file, that is my CSV file, into SAS and converting that into a SAS dataset. The SAS dataset will be created inside the HR library. You can create your dataset after importing in any other library you want. Here I am importing it and creating it inside my HR library. So I'm using the syntax proc import data file equal to within quotations I have given the path of my raw data file. So here is my raw data file HR. Inside my HR analytics folder hr_kai.csv. Just right click on it, properties, this is my location or the path of my raw data file. So here I'm just copying the location. Out is a keyword to create output dataset. So after importing the raw data file or CSV file into SAS, the output dataset will be created inside HR library and the name of the dataset will be Kai. You can give any name to your dataset according to your choice. Then replace semicolon and then run. Now let's run this code in order to import the dataset. So see, this data set is imported. You have three columns: employee ID, job satisfaction, and employee engagement. Now, in order to check the data dictionary part, or in order to see the overview of the data set, here we are doing proc contents on the data. So proc contents data equal to hr.kai and then run. So this is going to display the descriptor portion of your Kai dataset present inside your HR library. So see, there are 60 observations in your dataset. This is my dataset name. There are three variables: indexes are 0, observation length 24, deleted observation 0. Then you have engine or host dependent information. The most important part of the data overview is that you have the alphabetical list of the variables there in your dataset. So that is employee ID, employee engagement, and job satisfaction. Employee ID is a numeric data type. Employee engagement, job satisfaction, they are character data types. The maximum length of all the variables are given. They are 8. Formats and informats are also given. Now let's view the data portion of the dataset so that you can view you can see the entire dataset in form of a report. So for that we are doing proc print on our Kai dataset present inside the HR library and then run. So this is going to give you the data portion of the dataset. See, you have the three columns as it's there in the dataset: employee ID, job satisfaction, employee engagement. There are 60 observations, and in addition to that, you have the observation number column. Now we are going to perform the chi-square test on our dataset. So for that, we are going to use the freq procedure, that is frequency procedure. Proc freq data equal to hr dot chi. HR is the name of my library, Kai is the dataset. Then semicolon. Tables is a keyword to form the frequency table. Now this will be a cross frequency table. That is, we are going to generate one contingency table. Contingency table will be generated between the two categorical variables, that is employee engagement and job satisfaction. And we are going to do chi-square test. That's why we have used the keyword chi-square and then run. So let's run this code. So this is your contingency table where the first value is your frequency, second is your frequency percent, third is your row percent, fourth is your column percent. Now see, your employee engagement has three categories: maximum, minimum, moderate. Job satisfaction, three categories: high, low, and medium. So when you have this 10 means what? There are 10 observations whose employee engagement is maximum and who has high level of job satisfaction. Now this 16.67 is what? This is your frequency percentage, that is 10 by the total number of observations. Your total number of observations is 60. 10 by 60 into 100 is your frequency percentage. Row percent is what? This is 10 by row total, that is 10 by 28 into 100. That is row percent. Column percent is what? 10 by the total column, that is 10 column total, 10 by 16 into 100. So row total gives you the total number of observations who has maximum level of employee engagement, and column total is what? Total number of observations who has high level of job satisfaction, because this is your job satisfaction which is there in the column and employee engagement is there in your row. So this is all about the contingency table. Now let's move to the chi-square statistic part. See, you have the chi-square statistic value as 3.3673. The value which you need to know in order to interpret the result is their probability value, that is 0.4983, that is your p-value. Now since here your p-value is very much greater than your level of significance, which is by default set as 0.05, so you will accept the null hypothesis. And the null hypothesis of this test is what? There is no association between the two categorical variables. So based on the result which you have got from your chi-square test independence of attributes, you can conclude that there is no association between the two categorical variables, that is employee engagement and job satisfaction. There is no association between employee engagement and job satisfaction. So this is all about your chi-square test independence of attributes. This is how you do or implement chi-square test independence of attributes using SAS.